Good day everyone. Today we are going to discuss about the Unit 3, Software Components, Data Types, and Representation. Presenters, Erica Gilisania, Leia Hermogenes, Jerry Del Rosario Jr., Rafael Impreso II, and Lemuel Esganal Jr. Before we proceed to our discussions, let us feel the presence of our Lord and prepare ourselves for the prayer.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Our Father, who art in heaven, hallowed be thy name, thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread. And forgive us our debts, as we forgive our debtors. And lead us not into temptation, but deliver us from evil. Amen.
Again guys, we are 5 presenters today and let me introduce myself. I am Lemuel Esganal Jr. and the topic that is assigned to me to discuss is about system software. Are you all ready guys? Tara, let's get started. What is software? Software is the program and routines for a computer or the program material for an electronic device which make it run. The some examples of software are Mozilla Firefox, Google Chrome, PowerPoint, and Internet Explorer. System software is a software designed to provide a platform for other software. There are 5 types of system software: operating system, device drivers, utility, firmware, and translator. The first type of system software are the operating system. What is operating system? Operating system harness communication between hardware, systems programs, and other applications. Here are some examples of operating system: the Android, the Windows, and Mac OS. So how the operating system works? Here is a short video about operating system and how it works.
Computers are used for so many different tasks. Playing games, watching videos, running calculations, communicating and collaborating. Computers today are a mixture of different types of hardware and software. But there is one program that brings them all together, and that's the operating system. To consider what the operating system is, let's go back in time to the invention of digital computers. They could handle around 5,000 complex calculations per second. Impressive for the time, but today's supercomputers perform nearly 34 trillion calculations per second. Programs were written on punch cards, pieces of cardboard with holes. These were fed one at a time into the Central Processing Unit, or CPU, and enabled the earliest form of computer, batch processing. In some cases, one person was in charge of making sure the cards were fed in correctly. Their job was to correct jams and schedule when the next program could be run. As computers became faster, they were able to process punch card tasks quicker than the cards could be fed in. There was another problem. Different computers' resources, that is, the components within them such as RAM and the devices attached to them such as printers, were all different from one another. A programmer had to write very different types of programs specific to the machine it would be running on. Was it this card? Or that card? Oh no, it's all getting a bit complicated, isn't it? The solution was to write a brilliant piece of software called an operating system, or OS. The OS would take over the tasks common to many programs. Today, operating systems control the hardware of the computer. They manage and allocate resources and provide an interface for the user. Go on then, turn on that computer and we'll see what happens. An OS is one of the first programs that runs when a computer is turned on. Most programs start the same way. The computer issues lines of code as commands to prepare all the important elements, like the screen and the network. The operating system holds the collection of all the common commands and segments them, rather like putting them into a library, from which the other regular programs can borrow codes.
According to the video, operating system is one of the program that starts first when you are opening a computer. The second type of system software are device drivers. So what is a device drivers? Device drivers enables device communication with the OS and the other programs. Here are some examples of device drivers. The printers, computer sound blasters, and PCI adapter. To know more about device drivers, here is a short video to watch.
What is a device driver?
And what does it do?
Your computer is made of 3 major layers. We have the hardware layer, which are the physical parts, followed by the operating system layer, oftentimes referred to as OS, like Microsoft Windows, Linux, or Apple's OS X. And finally, the application layer, which is the layer you interact with. In a simplified version of this model, you interact with the application layer, which talks to the operating system layer. The operating system layer acts as a middleman between the application layer, what you do, and the hardware layer, the actual physical parts of your computer. Now, how many times have you plugged in or installed new hardware such as a printer, a scanner, a video card, or a network card for the computer to simply not recognize the new hardware or not work with full functionality? Well, that is where the device driver, or simply driver, comes into play. Let's imagine your operating system speaks English very well, and it is fairly well educated and can understand many different languages, but isn't fluent in them. Now, the most common and basic features on the computer hardware also speaks English, but not your new printer. No, your new printer only speaks French. Excuse me, sir. Could you please print this document twice and double-sided on the long edge, please? Quoi? Excuse me, monsieur. Tu peux imprimer le document flip-flop twice? Hey, Richard! Il veut qu'on imprime le document, je pense. You want la papier en tout? Document comes out twice, but not double-sided. Enters the printer driver, which acts as a translator built specifically for this device, speaking with the specific operating system. Excuse me, sir. Could you please print this document twice and double-sided on the long edge, please? Pourrais-tu, s'il vous plaît, imprimer le document 2 fois et recto verso? Document comes out twice and printed double-sided. So, the driver acts as a translator between the device and operating system. It is specific to the hardware device and the operating system. Sometimes the operating system will be able to communicate with the new hardware without you needing to install specific drivers, because some basic ones already exist built in the operating system, and it will be enough to get it to do basic tasks. But it is always a good idea to install the correct driver for each pieces of hardware in the PC. These can usually be found on the hardware manufacturer's product page under the Support tab. Thanks for watching.
According to the video, device drivers serves as a translator between the device and the operating system. The third type of system software is the utility. What is a utility? Utility ensures optimum functionality of device and applications. Some examples of utility are defragglers, disk cleanup, antivirus, and app launchers. For more description about the utility, here are the short video about the utility.
In this video, we consider utility system software. Encryption is a topic that you would have studied in 1.5 when you looked at network topologies, protocols and layers. Encryption utilities can also be part of the operating system. They use algorithms to scramble plain text into what is known as ciphertext. The text can only be decrypted and made readable again with a key. Encryption techniques may be very simplistic, such as the Caesar cipher, or they may be very complex, potentially taking computers hundreds of thousands of years to be able to decrypt the actual data. Defragmentation utilities reorganize files on a hard disk to put the fragments of files back together and to collect free space. This reduces the movement of the read-write head across the surface of the disk, and that speeds up access to files. Solid-state drives should not be defragmented. It's unnecessary because they've got no moving parts. They can access files quickly already. It also reduces their lifespan due to the way those devices actually work. Defragmentation typically includes taking all the fragments of a file, which you can see in this illustration represented by the blue, green, red and purple squares. And it takes all those fragments of a single file and it puts them towards the end of the disk, reorganizing those fragments all back together again. Once it's done that, it's able to free up sufficient space at the start of the disk and move the files back to the front. So the result is that all the files are contiguous one after the other, starting at the beginning of the disk, and then all the free space is collected at the end. Compression utilities reduce the size of a file so that it takes up less disk space and is quicker to download over the internet. Compressed files must be extracted before they can be read. So typically we might consider a video on YouTube. It needs to be compressed because you want to watch that video in real time. You need it to be streamed, and there would just be too much data, especially with high quality videos, for that to happen if the video was not compressed. Now, depending on the algorithm used, data is either lost during this compression process, which reduces the quality of an image or sound, and for example JPEG is a typical algorithm that would do this, or the data is represented in a different way using binary, retaining the original data in a new compressed format, and zip is an example of that. If we look at a very simplistic idea of how this might work, you can see in the illustration that we've got 8 ones, we've got 8 zeros, 8 ones, 8 zeros. We don't actually need to store every single bit. Instead, what we could store is the number of ones and the number of zeros. So here we've got 8 ones, followed by 8 zeros, followed by 8 ones, followed by 8 zeros. As long as we know that we started with ones, and then changed every time the bit state changed, then it's very easy to uncompress this data back into its original format. The number 8 means we need 8 ones, the number 8 means that's followed by 8 zeros, the number 8 means it's followed by 8 ones again, and then the number 8 means it's followed by 8 zeros. Very easy to reverse the process. And as a result, we've stored significantly less data. In this case, we've actually halved the data that we're storing. Backup utilities take a copy of files to protect against data loss, which could occur for all sorts of reasons. For example, you've accidentally deleted files, or you've had a malware attack that's changed the state of your files. Any number of reasons why this might happen. There are two types of backup, and you need to know the difference between the two. It's really important for exams that you're able to compare and contrast these. So a full backup means that every file is copied. With an incremental backup, only files that have changed since the last backup are copied. This makes incremental backups much quicker. So typically an organisation may do a full backup every week and an incremental backup every day. It's possible to go back through incremental backups in order to get back to a full backup. Modern networking operating systems actually automate this process, and they're so clever that they actually just back up the individual bits in files that have changed, and not even the whole file.
According to the video, utility is a kind of a system software that cleans, hardens, protect, and kill virus in the system. The some examples of antivirus are ABAS Cleaner, Clean Master, CCleaner, Recycle Bin, and other antivirus that is work 100%. The fourth type of a system software are the firmware. So what is a firmware? Firmware enables device control and identification. The example picture is a CMOS BIOS. So what is a BIOS? A BIOS is a firmware used to perform booting process and to provide runtime service for an operating systems and programs. Here is a short video about firmware.
Hello friends, my name is Amasu. Today we'll discuss about a topic that what is firmware. This is an important topic in software development and hardware handling. So let's start. First of all, I would request to please subscribe to my YouTube channel and also click on the bell option as well so that my new videos can reach to you. Also, you can follow me on Facebook as well. So let's start, friend. What is firmware actually? Firmware is a type of software that is etched directly into a piece of hardware. It operates without going through APIs, the operating system or device drivers, providing the needed instructions and guidance for the device to communicate with other devices or perform a set of basic tasks and functions as intended. Basically, friend, firmware is a software who directly reside on the device, and it directly talk with the device. Basically, this is the main concept of a firmware. Without firmware, the most basic of device would not function. That is why it is often stored on a read-only memory ROM chip, ensuring it does not get erased by accident, all while remaining as close as possible to the metal of the device. So device, basically the software exists on the chip based, like on a ROM based or read only memory. The software reside in the ROM, read only ROM, so that no one can remove the firmware from the device, because it reside on the read only memory, because the device cannot work properly without the firmware. Now friend, when a device is powered on, firmware is the first part to run and start sending instructions to the device processor to execute. If the device is simple as a keyboard, the firmware does not stop working as there is no software to replace it. However, in more complex devices such as PCs, laptops and tablets, there are often multiple firmware sets that interact to achieve a common goal: load the operating system. Okay, there are three types of firmware we should have to discuss here. First one is the low level firmware. This level of firmware is stored on non-volatile memory chips such as ROM, PROM, also known as one-time programmable OTP memory, and programmable logic array PLA structure. This is the low level firmware. Then the next one is the high-level firmware. This firmware is used with flash memory chips to allow for updates. It often has more complex instructions than low-level firmware, making it closer to software than hardware. This is the high-level firmware. Then the next one is the subsystem. A subsystem is a device or unit that is semi-independent part of a larger system. Because this firmware level has its microcode embedded in flash chips, CPUs and LCD units and is similar to high-level firmware, it often resembles its own device. So thank you friend, thanks for watching the video. I hope you like this video. If you like, please share it with your friends and colleagues, and thanks for watching the video. Thank you.
According to the video, or in a short definition, a firmware is a pre-installed system in your device or computer. Firmware also make the computer to the booting process, clear its data, and restore to its defaults. Important note: do not perform firmware doings when you are not capable to do it, because it can damage your computer or your device. The last type of a system software are the translator. So what is a translator? Translator translate high-level language to low-level machine codes. Popular translator language are compilers, assemblers, and interpreters. They are usually designed by computer manufacturers. Translator programs may perform a complete translation of program codes or every other instruction at a time. Here is a short video about translator.
Hi guys, in this video we are going to discuss on what is translators and the different types of translators. Let us consider two persons trying to communicate with each other. Here one person knows English language and the other person knows Hindi language. If they communicate with each other, it will not be a successful communication since both the guys don't know a common language. In this scenario, the translator comes into picture. The translator will be knowing both the languages and it will help them to have a successful communication in between them. Similarly, if a programmer wants to communicate with the computer, then there should be a translator who can convert the programming language into machine language. A translator is a programming language processor that converts a computer program from one language to another. It takes a program written in source code and converts it into machine code. It discovers and identifies the errors during the translation. There are three different types of translators: assembler, compiler, and interpreter. The assembler is used to translate the program written in assembly language into machine level language. If you guys want to know about what is assembly language, low level language, and high level language, then please watch my previous video. Then you will be understanding this concept very well. I'll be giving the link in the description. Coming back to assembler, here the source program written in the assembly language is given as the input to the assembler. The output generated by the assembler is the object code or machine code. Example for assembler translators are FAP, Fortran assembly program, and MAP, macro assembly program. Compiler will convert the high level language into machine level language. It will read the complete source program in high level language, and if the code is error free, then it will convert it into machine level language. If there is any error in the source code, then the compiler will specify the error at the end of compilation process. Let us do this in practical and we'll check. Since there is no error in the code, the compiler waits till the end of compilation process. Once the compilation is done, then it will print the output as shown. Now we will create an error by removing the semicolon from 5th and 7th line. Then the compiler will begin from first and it will identify the error at 5th line. But it won't stop there. It will compile till the end of compilation process. Once the compilation process ends, it will throw both the error 5th and 7th line. But here it won't give any result. It will throw only errors. Example for compilers are GCC, GNU Compiler Collection, and COBOL, Common Business Oriented Language. Just like compiler, interpreter also used to convert high-level language into machine-level language. But it converts one at a time. It will do step-by-step execution. With this, it is easier to detect errors than in a compiler. It is faster than a compiler as it immediately executes the code upon reading the code. It will go to the first line, then it executes. Next it will go to the second line, it executes. Next it will move to the third line. And if it finds any error, then it will stop there and it will print the result. But it won't execute the fourth line. Let us do this in practical and we'll check. Here we are using Python as an interpreter. Since there is no error in the code, it will do step-by-step execution and it will throw the output. Now we will create an error in the third line. We will remove T from print. Then we will rebuild the program. Then it will print hi everyone, which is there in second line. When it go to third line and it will execute, at that time it will find that error and it will print that error. Further it won't be going to fourth line. It will stop at third line itself. But it will be printing second line hi everyone. But in case of compiler, it won't print any result. Example for interpreters are Python and Lisp, list processing.
To the video, there are three types of translator: the compiler, interpreter, and assembler. Some example of compiler are the Common Business Oriented Language, or called COBOL, and GNU Compiler Collection, or called GCC. The some example of an interpreter are the list processing Python. The some example of an interpreter are the list processing Python. Some example of assembler are Fortran Assembly Program or PAP, Macro Assembly Program or MAP, and Symbolic Optimal Assembly Program or SOAP. I guess I'm done. So thank you everyone for listening. I guess the next presenter is ready. I think she is now ready. Bye guys!
Thank you, Limo, for that wonderful presentation. Again, good afternoon, everyone. Since Erica is not around here today because she is a participant for the Pa-English English 2021, I'll be the presenter of her finished PowerPoint presentation about the topic Application Software. But before anything else, I prepare a short video for you about the topic that I'm going to discuss today. So, play.
What is application software or application program? An application program is a computer program designed to perform a group of coordinated functions, tasks, or activities for the benefit of the user. Examples of an application include a word processor, a spreadsheet, an accounting application, a web browser, a media player, an aeronautical flight simulator, a console game, or a photo editor. The collective noun application software refers to all applications or app collectively. Applications may be bundled with a computer and its system software or published separately, and may be coded as proprietary, open source, or university projects. Apps built for mobile platform are called mobile apps. Let's look into the type of application software. Application suite has multiple applications bundled together. Related functions, features, and user interfaces interact with each other. Enterprise software addresses an organization's needs and data flow in a huge distributed environment. Enterprise infrastructure software provides capabilities required to support enterprise software systems. Information worker software addresses individual needs required to manage and create information for individual projects within departments. Content access software used to access content and addresses a desire for published digital content and entertainment. Educational software provides content intended for use by students. Media development software addresses individual needs to generate and print electronic media for others to consume.
So let's start. According to the video, the application software or application program, it is a computer program designed to perform a group of coordinated functions, tasks, or activities for the benefit of the user. So basically, application software are computer programs, and its goal is to help the end users or us to make our tasks done on time or early. So some example of application software are word processors, spreadsheets, accounting application, web browser, media player, photo editor, and many more. So apps built for mobile platforms are called mobile apps. So all the applications that you can see or that are available on your phones, they're called mobile apps. So let's proceed to the different types of application software. First is the application suite. It has multiple applications bundled together. Related functions, features, and user interfaces interact with each other. So some examples of it are the Microsoft Office and the Apple's iWork. If you're going to observe the Microsoft Office, it made up of Microsoft Word, Microsoft Excel, Microsoft Outlook, and Microsoft PowerPoint. While the iWork is for Apple or Mac, and it had Pages, Numbers, and Keynote. And you're going to if you're going to differentiate the Apple's iWork or Microsoft Office, it like they are all similar naman because Pages is similar to Microsoft Word, while the Numbers is similar to Excel, and the Keynote is similar for PowerPoint. So the second one is the enterprise software. It addresses an organization's needs and data flow in a huge distributed environment. So I have two examples here presented in the PowerPoint. The first one is the teamwork, and it symbols like a T. So teamwork is a cloud-based project management solution that provides businesses functionalities to manage different operations of a project. So its features include task lists, time tracking, file uploads, and messages. So teamwork helps teams manage group objectives, communicate, and establish business processes. So the second one is the Zoho project. So Zoho projects is our cloud-based project management software. It helps you plan your projects, track work efficiently, and collaborate with your team wherever they are. So an outstanding service for project management, Zoho Projects packs more features than many other project management tools. So the Zoho Projects claiming that they have more features than many other project management tools. So they saying that they are so much advanced. So the third one is the information worker software. It addresses individual needs required to manage and create information for individual projects with departments. So some examples of individual needs required to manage is the time management, resource management, analytical, collaborative, and documentation tools. So these examples are some application software that belongs to information worker software. Word processor, email, or personal information systems such as Facebook, Google Chrome, Apple ID, and individual media editors such as Photoshop and Notepad. So these application software may aid multiple information worker tasks. So the fourth is the content access software. It used to access content and addresses a desire for published digital content and entertainment. So some software that belongs to content access software is the media players and the web browsers. So these softwares used primarily to access content without editing, but may include software that allows for content editing. For example, I want to create another content using a photo from Google Chrome, which is a type of web browser. But when you get into the website, you can't edit the photo right away. So you need another software to make that thing done. So first you need to download the photo and using another software which is a photo editor like Photoshop or Canva or any photo editors that can open that photo and then you can edit it and so that you can create another content. So to make it more easier to understand, content access software is it is used to access different contents and you can't edit it right away because not all the time, but not all, but most of the time you can't edit it because you need another software to make that thing done. So the fifth one is the educational software. It provides content intended for use by students only. So some softwares that belong to educational software are the Photomath and the Moodle or even some educational games. It are all included on educational software. So the last one is the media development software. It addresses individual needs to generate and print electronic media for others to consume. So some examples that belong to media development software are the Adobe Animate and the Flipaclip. So most often, it is um, used for commercial or educational setting includes graphic art software, desktop publishing software, multimedia development software, HTML editors, digital animation editors, digital audio and video composition, and many more. So this is for today. I hope you learned something about application software and I think Manon Cherry is now ready for his presentation. So goodbye and have a blast everybody.
Internet break! Have a break! Have a Kit Kat!